kind of mini presentation on Azure CosmosDB. And I would like to say both Microsoft and Phidiax for hosting and organizing this event. My name is Sergei Isayeu. I'm basically cloud architect for a company called Chamberlain that's based in Chicago. I moved from Chicago to Denver about 9 months ago and totally loved it. Probably the best thing I did for myself for a couple of years. But let's talk about CosmosDB, NoSQLDB, what it is, how it can help you, where to use it, and what's also about it. Quickly, we'll talk about just general overview and concepts, couple use cases of who use it and who doesn't. Take a look at the portal, take a look at geo-distribution and multi-region development, consistency models and partitioning, and then there will be a really quick demo. Not as cool as that bots demo, but still something like that. I'll be mostly focusing on DocumentDB, part of CosmosDB, but before I do that, basically the history of CosmosDB is that initially it was Azure DocumentDB. Pure NoSQL, just JSON content, right? Microsoft rebranded it, I think, about a year ago or a couple years ago, and over time, since that time, added some additional APIs and functionality. Basically, right now, it's multi-model, multi-API database. You can store your JSON there. You can use standard kind of quote-unquote SQL API, MongoDB API, Cassandra API. You can store table data, and they actually add that graph API in there too, so you can store graph data. I'll be focusing on DocumentDB part of it only. So multi-model, multi-API, one more kind of slide on this. These are all the APIs that are available. You have a lot of native APIs and native frameworks to basically connect with native clients, which is awesome. Native clients come with some additional features that we will cover in the slides. At the same time, you can always use REST API model and basically from your query language or your language to use, do REST API queries and do whatever you want to do with any of those APIs and models. And to the DocumentDB at a glance. Basically, it's NoSQL database as a service fully managed by Microsoft Azure. Fun part of this that I recently did an overview of DocumentDB for my database operation on-prem guys, and they're like, all right, so what do we do over here? Right? I'm like, not much. Request units maybe, and just monitor that everything is fine, and that's it. So which basically reduced operational needs significantly. Right optimized, tunable consistency, schema agnostic, automated and configurable indexing, and so on. Out of important things over here is automated partition management, right? If you're running it on a partition model, massively scalable, and you don't have to worry about disk space, SSD-based, SSD-backed, right? So really good SLAs and basically performance. So how is it different, right? There are quite a number of different NoSQL databases out there, right? Why to take a look at this one? Guaranteed low latency, global distribution with push of a button. You can distribute your regions all over the world, and it literally doesn't take much stuff, just a couple mouse clicks, and you have your basically data available in Australia or Europe or anywhere you need. And at the same time, it's backed by Microsoft SLAs. These are some performance metrics that you want to see. Half of the reads are execute on the database side within 1 millisecond, right? Within 6 milliseconds. 99% of reads within 10 milliseconds and writes within 15 milliseconds. And you can scale it from 400 request units, which is basically really good for POC or demo or for your developer to play with, to hundreds of millions or tens of millions requests per second for your production database, if you need that scale. Synchronous indexing, basically lazy indexing or consistent indexing depends on your needs. You can include or exclude fields, whatever it is depends. Elastically scalable storage, basically if you're running it on partition model, right, Azure will allocate storage as it needs to, you don't have to worry about it. You can independently scale storage, well, basically Azure scales storage for you, right, and you basically do it throughput, right. on the database. No partition management. And one of the nice features of DocumentDB is document expiration, which can be great for your, say, login data, audit data, telemetry data, and so on. You don't have to, say, manually clean it up after the fact. You can just set it up like after a year expires the document. Again, simplifies and optimizes development. Really interesting stuff. Enterprise grade SLAs. 4 nines for read availability in a single region, 5 nines read availability multi-region, which is honestly great. Like 5 nines end up in probably like 7 minutes potential downtime over the year, right? Which I don't think is really achievable, right? Unless you invest really a lot of money into it. Well-defined consistency models. If you're running a geo distributor, right, you end up facing cap theorem, right? No way around it. Azure helps with that. You have 5 defined consistency models that you can choose from. Strong, bounded stateless, session, consistent prefix, eventual. Strong basically works only in single region development, right? The next to it, bounded staleness, is it close that gets to the strong consistency for multi-region code, right? We basically use consistent prefix for most of our stuff, which basically guarantees that your reads never get out of order writes, right? Or eventual for stuff like login, audit, and things that can get consistent eventually, and we don't care if you don't get the latest and greatest right now, as long as it's eventually consistent. Total cost of ownership. DocumentDB, honestly, not that expensive, right? You have to be careful on request units and basically on your partition keys, right? And then your DocumentDB has one of the best total cost of ownerships across most of the databases. Cool. Who uses DocumentDB? A lot of clients. This slide was prepared probably half a year ago, right? And since that time, Microsoft heavily updated their documentation information on who uses the slides, and they have a lot of really awesome use cases, right? And by the way, during coming MS Build conference, they'll be presenting some of the use cases from clients. I highly advise to take a look at it. There will be one on microservices and DocumentDB. There might be one from the company I'm working for. We'll find out. Couple use cases again. Microsoft uses DocumentDB LTOL for their own backend. Skype, IoT Hub, Toyota uses in IoT, kind of structured deployment, and a bunch of games use it too. This is interesting case of jet.com. Why is this interesting? This kind of shows the scale of the DocumentDB that you can push it to, right? 10 million requests per second throughput, 12 terabytes of data provision, right? 64 databases, and also right on the slide you can see the DocumentDB plays fairly well with Azure Service Fabric. I personally used it as a persistent mechanism for Service Fabric and for microservices hosted there. It works very well and extremely fast. Couple use cases, really nice diagrams from Microsoft again, right? Data being pushed through IoT Hub, Azure CosmosDB, state data, telemetry data, and so on, right? Azure Web Jobs processes through change feed, basically subscribe to change for the documents, process it, and act on devices through either logic tabs or directly, right? I'm not sure that you need all the components, right? But storing state of the devices doesn't make sense. And that's actually, for me, surprising to see how IoT actually gets into our life. I have a Roomba vacuum cleaner, and there was a problem with that. I called Roomba guys. They remotely debugged the problem on my vacuum cleaner at home, fixed it, and the stuff works. It was awesome. They refused to tell me what exactly they fixed, but I think they turned off one of the sensors that was broken on the device. There were 2 sensors. They turned off one, and then stuff started working. Use case, product catalog and inventory management. This I think goes to the jet.com example, right, where you have basically your web front-end APIs, product catalog stored in CosmosDB, and this is actually awesome use case because on your product catalog you don't have that many writes, but you have a lot of reads, right? So you can actually tweak and optimize your CosmosDB for heavy read, right? And by that you're not paying much, and you're getting a lot out of it. And integration with Azure Search, you get like full search capability on top of it. So, and this is basically another side, order processing. Again, your orders being saved on CosmosDB, right? Then processed for fulfillment, and data is exported for your big data and analytics, and whatever your, I don't know, analytics guys want to throw. Whew. I like this use case. This is similar to what we did with, let's say, our code data and our traffic manager. The good stuff about this particular diagram is that you can see that user requests come from basically users, right? They end up on the Azure Traffic Manager, which basically routes it to the most available or closest region, right? And the data is available, the same data is available in all those regions automatically, right? So you don't have to synchronize database, or you don't have to do cross-region database calls, which is awesome. We use similar to this architecture in one of the basically projects that we use. Whew. All right, DocumentDB, model and portal walkthrough. Really high level. Database model is DocumentDB account, which is basically a collection of databases. Underneath databases, there are users and permissions, right? Which is, you have to have that. And collection is basically your main data store for your JSON documents, right? All JSON documents are belonging to one collection only. Within collection, you can also define your own stored procedures, triggers, or user-defined functions. Stored procedures can be mass update of something, cleanup, or something like that when you need to act on many documents at the same time and you don't want to make multiple requests to the database. Couple things to note. Model is hierarchical. This actually lays out to really nice URL structure if you do REST API requests. Right, we personally use .NET client, right, so we don't really worry about it that much. But this basically lays out a really nice database / collection / document ID, and you can use get posts whatever you want to do with stuff.
Excuse me?
Yep.
Is that still true that JavaScript is our only coding language for the stored procs or user-defined functions?
I would think so, right? I haven't heard any announcements, and I don't work for Microsoft. That's a disclaimer, right? Double check on it, but I haven't heard anything that they have added additional.
Okay.
Portal walkthrough. Let's go to this. All right. This is the sample database that I have provisioned specifically for this demo. This is an overview tab. Important things to take a look over here: list of collections, measurements, database, provision throughput. I provisioned quite a lot, 20,000 requests to use per second. I provisioned even more when I was loading data. I loaded, I think, 2.5 gigabytes of data, and it took me 1 hour with, I think, 30K throughput. And what's awesome about it is that you can provision your throughput, do whatever you need, right, and simply provision throughput, and you're not paying for it. It's very scalable. One of the most important tabs over here, Data Explorer. Microsoft consolidated a lot of stuff from browse, scale, settings, and so on into just Data Explorer over here, and it's generally available right now. You can see your documents over here. Boom. My document basically models a measurement from IoT device. This is something that I'm working with recently, right? So why not demonstrate it?
Yeah, not to derail your presentation, but did joins do anything in here at all?
Joins.
Yeah,
joins.
I know they have joins, but I don't. You can't join between collections.
Between collections, I don't think so.
Yeah.
Yep.
You never use it, I take it. You're never tried.
We never tried it, right? What we do, we try to use our JSON to get as flat as possible, maximum 2-3 levels of hierarchy, right? Just for simplicity reasons. If you really need to do hierarchical data, right, why not make it a relational database?
Right.
Especially if your model doesn't change the document. You can basically add a filter over here, right? It supports a lot of features of typical ANSI SQL, right? Conditions, queries, and so on, right? You can go a couple levels into your basically JSON document, right, and querying it. For example, let's see, and let's see if this works. This is demo, so something should go wrong. And I think that's boom. All right, and boom, we have filtered documents. Right, you can go a little bit deeper on this stuff. Right, you can do, let's say, this. I'm actually wondering what will happen. I haven't tried this at home.
There's a library for document. Document core.
And we can filter it to one document out of all this, right? So over here you can take a look at your documents. You can edit it if you want to. You can change something over here, right? And update if you want to. You can again restrict it if you want to, so your engineers or developers cannot update it manually in production or anywhere. Again, it's up to you. Scale and settings, this is where you manage the stuff. You can change your throughput from anywhere to, I think, 1,000 right now to 50,000 per use. Right, I can change it right now, and this will basically descale it. Right, time to live, I can set it up on the level of collection in any number of seconds. Right, and over here you can see indexing policy. I'm using default consistent one. You can tweak your indexing policy, and this will basically affect how many request units will be taken for your rights, right? Because indexing applies on rights. Stored procedures and so on. Typical stuff. Keys. You can have read-write keys and read-only keys. Again, it's really help for security for database. If you want your application to just read stuff, why not read on use only read-only keys? And probably the tab that you will be spending a little bit of time at, right? Just monitoring or setting up your alerts. If you want to, this is basically metrics. Important stuff, number of requests exceeding capacity. Let me see if I could get the point. Boom, this was the moment when I was loading my data to database, right? So I exceeded my streaming capacity. Then I scaled up and everything went back to normal. Data and index storage consumed. You can see that I am about 0.4 gigabytes for index and slightly more than 2 GB for data. In this case, this is where indexing policy plays the role. And so on, right?
The point where it exceeded throughput capacity when you were uploading, does it just simply throttle?
It throttles, yes.
Yeah, okay, so there's no error thrown, just simply.
It depends to what level you push it, right? If it's just slight throttling, you find, right? You can set up retry logic on your client, right? And just retry it. If you say provision 400 request units, you send a couple millions, it will just block it. I would think one more interesting thing over here, right? If you take a look at storage, you can see that my collection is partitioned, right? And over here I can see how basically DocumentDB combined my partition keys into partitions. So in partition 1, I have 3 partition keys, right? In partition 4, I also have 3 partition keys, and so on. This example is slightly artificial because it's demo, right? In real life, you will have slightly different allocation of number of partition keys to partition, depending on how much data you have. Now, questions so far?
Now, on a distributed, you have a distributed database, one in, say, one in New York and one in Asia.
Right.
How long does that actually take to seek out the you update it?
It depends on your consistency policy, right? For the strongest one, it will have to wait till it gets to basically most of your endpoints, right? That's a good question. I think cross-region about 50 milliseconds, right? That's
It's nothing to complain about.
Exactly. I mean, United States, Azure, not too bad. Right. If you're in a lazy model, right, your writes will be almost immediate, right, and the data will be sent to Azure basically. Actually, you brought really good point. If you go to metrics, consistency. Over here you can see consistency model, right? How it changes over time for me because I did a lot of data ingestion. It took a little bit of time for it to catch up, right? And you can monitor it. And actually, there is really nice articles that I really wanted to read but never got to. About it. Propagates over time. If you read it, let me know. Okay. How am I doing on time? Oops. That's correct. Distribution. Awesome. DocumentDB is basically available in all regions. You can elastically scale it across any number of regions, right? You have one write region, you can have as many as you want regions. You can move write region around at your personal desire. You just need to have one. Basically, you should allow your client to do discovery of write region, right? And by that, when you move write region, your application will do downtime to automatically switch to the right region by itself. You can take regions online and offline. You can change consistency models if you want to, and you can dynamically configure your reads and write regions. If we have time, I will show you the demo.
Can I program this to roll through regions at certain times ahead of time?
That was best kept secret. Yes, you can.
Okay.
You can write, for example, Azure function or something, right, that actually moves your write region through the world as an actor. This is an example of somebody putting their DocumentDB all over the world. You can do that if you want to. Why would you do it? Multi-region development, right? Scale out reads throughput, right? If you have a lot of reads, right, you can put reads right exactly where your customers are. Basically CDN-like basis, right? Your data is where you need to be. DocumentDB will automatically fail over if one of the regions goes down and basically you don't see it on your client side. It's handled by framework. And Azure SDK functions use discovery protocol to understand what endpoints are available and which ones it is. This is an example of typical multi-region development when you are putting your front end, back end, and data in the regions where your clients are. Over here you can see that both code and data is in United States, Europe, and actually Japan. So basically latency for your customers is really low. It's local latency, it's not cross latency. Couple code things, right? If you want to use SDK and you use C#, right, in the client configuration, you want to add the preferred locations to the connection policy, right? And by that, you'll be able to instruct it to connect to particular points. And you can actually inspect using document clients write endpoint and read endpoint where it connects to. I'll show it in the demo. It's like super simple and it's awesome for operations people to see what's going on and for developers. Consistency model with due deployment, right? You end up being facing cap theorem, right? So you need to navigate it somehow. 5 different options, right? Eventual on the right is the most kind of performant and the least price option. On the left, least performant, most price options in terms of request units. Right. It again depends on your application. If it's financial data, right, you might want to use strong consistency or bounded staleness. Right. If it's just reads, you don't care. Eventual consistency is fine. If you populate your product catalog up front, eventual consistency is fine, and you are not incurring extra RU costs. Partitioning. DocumentDB can be deployed in basically two ways. One is non-partition, and you can store only 10 gigabytes of data in one partition, right? So your data cap is 10 gigabytes. If you want to need to store more data, you need to go partition, right? And one of the most important decisions you need to make is what the partition key. It's immutable, and basically when you create a collection, you define partition key, and that's how DocumentDB will kind of scale it out and put documents in particular partition. It used to be that minimum throughput for partition collection is 2,500 request units. They dropped it to 1,000 request units recently. Basically, lower and more cost. And I think 400 request units DocumentDB costs like $30 a month, which is nothing. It's awesome. Considerations, right? Again, it's immutable. Critical design consideration, Microsoft highly recommends, and I mean, in my practice too, that the best thing you can do is to come up with potential partition keys and then run a couple load tests and see what you actually get. Because your assumptions might be different from reality, right? And it's much better to do a couple tests up front than find out that something is wrong when you have a couple gigabytes of data in the database. On the left, you see diagram when people chose different wrong partition key, right? And they have actually had spotting. Basically, one of their partitions, couple of their partitions are being used way more than other partitions. On the right side, you can see that people chose quite a good partition key, right? And it's more or less evenly distributed. How much time do I have?
Just 2 more minutes.
All right. I will skip querying for data and design considerations. Again, pick good partition key, right? If you have a lot of users, user ID is a good partition key. IoT, device ID is partition key. If you have multi-tenant deployment, tenant ID can be good partition key. We'll skip integrations. It's super simple, right? Everything within documentation, but you can integrate with other functions like logic apps, search, and so on. And you can actually query your data through Power API. We do that, it works pretty well. And quick demo. I wanted to do some sort of kind of research for myself, right, and see how much actually queue distribution affects requests, responses, and latency, right? And I did this test basically from my own machine, right? And let me maybe first go through the data that I've collected, and then we can run this test over here. So this is the first one, kind of architecture and deployment. My database in US West, right? My clients' APIs are in West Indies, right? And when I run the test, I get these numbers, right? I see the median latency is 134 milliseconds, which is not terrible, right? 26 requests per second from my home machine on Postgres, which is not great, but as test, it's good. Then I did a test on basically putting grid replica in UAssist, right? And pointing my API in UAssist for read requests to go to the replica. Boom. Our median latency dropped like twice, right? If you take a look over here, it was 134 milliseconds, and then boom, it's 66 milliseconds. We basically saved our customers a significant amount of time. And if you need to do a couple queries, right, you realize that instead of your customer waiting for data, you can see it immediately. And then I did another test, right? I put my basically load generator and measuring tool in the cloud, in the US West VM, right? And that's the only thing that I changed compared to the previous test. And if you take a look over here, you can see drastic difference. Basically, median latency dropped to 6 to 10 milliseconds, right? And my request per second increased to 353. What I'm trying to say over here is that in like these numbers, it's all network latency, right? And over here, it's more or less how much it takes for DocumentDB to process the request and for my web API to serialize and deserialize requests, right? Which makes me personally think that this geo-distribution feature actually works, right? And allows to significantly cut down like request response time for user interactive applications. Questions on that? maybe. Nope. I guess then I can actually finish early. Couple tools. Basically, Portal is your #1 tool, right? You can use it to navigate. If you don't like Portal, if you don't want to go online to see your data, there is Azure Search Explorer that allows you to connect to your database, right, and see your documents, run queries, do whatever you want to do. There are a couple third-party tools. For import-export, you have a couple options, right? You can either do integrations that are provided by Azure to export your data into the storage container somewhere, or you can actually run, I think it's document exporter or something else from Azure that allows you to basically say, I want this subset of data, save either on my disk or somewhere else, and it will do it for you. A lot of useful links. I would think the best one is Azure Blob, right? And latest news and roadmaps. That's where you can see what's going on and what's new stuff. That's Microsoft is coming up. If you're already in Azure, talk to your account manager from Microsoft, right? And make them to get CosmosDB architects or product managers to do a presentation and demo for you and answer your specific questions. Those people are very helpful. They helped us a lot, and they will probably help you a lot. And I would say take a look at the MS Build conference, right? I would expect there will be interesting announcements about CosmosDB and DocumentDB, and there will be also a couple success stories that might help you to kind of design and test out your own services.
The data model, do you have to pick that up front, like which one you're going to use, or can you mix them within the same?
Right. Data model, you cannot mix it up, right? Basically, when you're creating your DocumentDB account, right, that's when you're selecting your data model at this point.
So the relational model of SQL, is it SQL Azure running in Cosmos? Or?
No, SQL in this case, it actually applies to SQL query language. Right? It means that you can use SQL-like queries to query your NoSQL database.
Okay.
And NoSQL database, you basically store JSON documents. Right? That's what SQL is. SQL is here. Right?
Okay.
You don't have typical like relational database over here. Right? You can emulate relational database through JSON models, right? But it's not typical NoSQL. Anything else? Well, thank you.
So, like reporting on top of it, what have you done some stuff where you put some type of reporting engine on top of it then?
What we did, we did one thing. We basically put Power BI on top of it, right, and use Power BI for our analytics, right? If you want to do more complex stuff, or if you want to use your own data store for analytics, you can subscribe to ChangeFeed. ChangeFeed is basically a feature of the DocumentDB where you can query all the changes to the documents, inserts, updates, deletes, and so on, right? And you can basically save them to your own data storage in any models that you want, right? And do your own analytics and queries the way you want. Well, thank you so much for your time, then.